Welcome to NPTEL online courses on fractals and multifractals. In previous weeks, we have discussed the history of fractals and the construction of fractal in the metric space. Especially, we have constructed the fractal as an invariant set of an Hutchinson band-slave mapping on a non-empty complete subset of a given space. Then we have the systematic way for constructing the fractals, and we discussed the deterministic algorithm and random iteration algorithm to generate the fractal. Now, as an application of fractals, in this week's and coming lectures, we are going to discuss the fractal interpolation in the field of approximation theory. So, what is the difference between classical interpolation and fractal interpolations? Both the interpolations functions or methods construct the continuous function which passing through the given number of data. So, by using both the method, one can obtain the missing data in the given set of data. Say for example, if we have certain data from certain period, if some data are missing, then by using or interpolating the data, one can obtain the missing value. So, the classical interpolation usually interpolate the data by using the spline function, and oftenly it is a differentiable function, whereas in the fractal interpolation function, it interpolate the data, though it is a irregular data, it interpolate it with the self similar property. So, if the data is irregular data, the classical interpolation gives the or approximate the given data by using the continuous and smooth function, whereas the fractal interpolation approximate them by using the appropriate function, which is mostly nowhere differentiable function. Sometimes we are generating the differentiable fractal interpolation function for approximating the given set of data. So, in these lectures we are going to a detailed discussion about the fractal interpolation. So, we will begin with this lecture by defining what is the interpolation in the classical sense. Let x1, x2, xn be a partition of the closed interval x1 to xn, which is a subset of the real number r. That means, if we have the interval x1 to xn, closed and compact interval, then this points x1, x2, xn partition the given interval. There are different type of partitions is available. So, if the partition in the sense x1, x2, x3 dot dot dot, this is xn minus 1, this is one type of partition, where here the points are equally distributed, the distance between any two points are equal. Whereas, if you consider this the same interval x1 to xn, the closed interval x1 to xn, one can partition by using like this type of partition x3, this is x4, x5 and so on, here xr, here xr plus 1 and dot here may be the xn minus 1. So, difference is here these points are equally distributed in this interval. That means, these points are divide this interval equally. So, this partition, whereas this partition, these points divides this interval in the unequal manner, that means the partitions are not the equal partitions. Now, only constraint we are taking the partition points in the increasing order, that means x 1 less than x 2 and less than x 3 etc., x n minus 1 less than x n. That means, if you are taking any point here, x I is less than the x I plus 1 for all I belongs to 1 to up to n minus 1. It will satisfying this one. So, we considering this as a increasing sequence. Now, consider the data points x I comma y I, which is in the space of Cartesian product of the closed interval to R. There are n number of points. So, consider this n order tuples. There is an error here, this is an error here. So, let this data point is given, this data point also called as the interpolation point, and the interpolation function f is a continuous function. F, the function from x 1 to x n to R satisfying f I of x I equal to y I. That means, if you are considering the real plane, if my data point is x 1 to x n, x 1 to x n. So, I am taking here x 1 and here my x n, then that y I may be given here and here and here, here and here and here. Maybe this is y 1, this is y 2, this is y 3. Oh, sorry, not y, this is for corresponding to x 1, y 1 is here, corresponding to x 2, y 2 is here, corresponding to x 3, y 3 is here, and corresponding to x 4, y 4 is here, and so on. Then this function f is continuous from the interval, closed interval x 1 to x n to R, satisfying, if you are taking x 1, it will goes to here, and x 2 means it should comes here, and x 3 means it should, x 3 is here, x 3 and x 4 and so on, it goes like this one. So, for the given set of data points, that means the given set of interpolation point, the interpolation is a continuous function which satisfying this equation. That means, for every x I should be under this mapping f, image of every x I should be equal to y I. So, now in the interpolation theory, deals the existence and uniqueness of the continuous function which passing through the given set of data point. If any data point is given, how to construct the continuous function which passing through the given set of points. This is the major role of the interpolation theory. There are many methods available in the classical theory of interpolation. Let us discuss some very fundamental things to construct the points. That means, if this points are given here, say for example, one point is here, one point is here, one point is here, maybe one point is here in R power 2. How to interpolate this data point? But simply finding the continuous function. The simple idea is, one can draw the straight line from here to here and here to here and here to here and sum it all. Then this is the simple and easiest way to find the continuous function which passing through the given set of data points. So, for finding the distance between two points in the xy plane, if the x1 y1 and x2 y2 is given in the R power 2, then this x1 and xi comma yi given in R power 2, then finding the straight line between given set of points, that means finding the distance between these 2 points, one can use this formula. That means f of x equal to y 1 plus y 2 minus y 1 by x 2 minus x 1 time x minus x 1. So, for every x belongs to this closed interval x 1 x 2, this is 2. That means, if you are taking 2 points, for finding the continuous function between these 2 points, one can join the straight line. One can join the straight line. The straight line equation is given by this equation. So, if anyone want to find the missing value in between these 2 points, for example, if one point is given corresponding this for this x, if you want to find the y, one can apply this equation to get the y value. So, now let us discuss some example related with these formulas. Consider the data set 0, 0 and 1 by 2, 1 by 2 and 1, 0. Now, the data points are 0, 0. So, 0, 0 typically here, maybe I will use the different color to mention the points. So, 0, 0 is here and 1 by 2 is here and 1 by 2 here. So, this is the 1 by 2 and 1 by 2, and other one is 1, 0. So, 1 in the y x axis 1 and y axis 0, the point is here, this is 1, 0. Now, we have the 3 points 1, 2, 3. Now, we need to find the interpolation function in the classical sense, which interpolates in this type of data. So, we need to find the line joining 0, 0 to 1, 2. So, we need to take x 1 and we need to take this formula x 1 y 1 and x 2 y 2. So, x 1 and y 1, which is equal to 0 and 0, and x 2 y 2 we need to take 1 by 2 and 1 by 2. Then we need to find the line joining these 2 points. So, for this one, the formula is given here. So, y 1 plus y 2 minus y 1 over x 2 minus x 1 times x minus x 1. One can get the line joining this equation f of x. So, y 1 is we can get 0 and x 1 is also 0. So, this term is x, y 2 minus y 1 is 1 by 2, x 2 minus x 2 is 1 by 2, this will cancel, one can get the y equal to x. So, this is the this line, one can get 0, 0 to 1 by 2, one can get this straight line. Similarly, if applying the same formula on these 2 points, one can get the line joining these 2 points. So, now this function f1 of x equal to x and f2 of x equal to minus x. So, we need to define the proper interpolation function f of x, the interpolation function, which is equal to minus x, this is defined as minus x if 0, this is 1 by 2. So, if we are taking the points from this interval, if the x belongs to 0, 1 by 2, we need to take x. It is gives the value minus x if one take the points x is belongs to 1 by 2, 1. If this interval, this is the function. Now, this is the function and this is the function which passing through the given set of points. So, now as per the definition of interpolation theory, if you take f of 0, one can get f of 0 is 0, f of 1 by 2 is it is equal to 1 by 2, in both the things it will get 1 by 2, and if you are taking f equal to 1, then one can get f is 1, you need to take the, if it is 1, yes, it is right. If you are taking f of x equal to 1 by 2, f of 1 by 2 is 1 by 2, if you are taking f is as 1, So, it comes here, it is 0. So, 1 is 0. So, this is the given function which interpolates the given set of points. So, for finding this one can apply to find this interval. For finding the formula, one can apply f of x equal to, here take x 1 and y 1, x 2 and y 2. So, now x 1 value is 1 by 2 and 1 by 2, and x 2 is 1 comma 0. So, y 1 is 1 by 2 plus y 2 minus y 1 is 1 by 2 over x 2 minus x 1 is 1 by 2, x minus x 1, x 1 is off. So, you can get y 2 minus y 1 is 0, this is minus half, and x 2 minus x 1, 1 minus half is half. So, this will get cancelled, then this becomes half plus 1 by 2 minus x. So, it will get, one can get 1 minus x. So, this is not minus x, it is 1 minus x. So, if you are substituting, this is the typos, here it is not a minus x, this must be a 1 minus x. So, if you are taking 2 points 1 by 2 and comma 1 by 2 and 1 comma 0, one can get the value as 1 minus x. So, this function is 1 minus x. Therefore, if you are substituting 1 by 2, this case also one can get 1 by 2, in this case also 1 by 2, because it satisfying this join up condition. In both the case it is satisfying, fine. So, here is the function given by, this is actually the 1 minus x. F of x in the interval 0 comma 1 by 2, the value is x, in the interval 1 by 2 to 1, the value is 1 minus x. This is a obviously continuous function. As we discussed the definition of continuous function, simply we can draw the figure without taking the hand simply. So, this can be a example of the continuous functions. Also, it passing through the given set of points, and one can say that this is the classical interpolation function for interpolating the given set of points here. Now, this is the figure which is given here. This is f of 2 is 1 minus x, that we can verify. Yes, fine. Consider the data point, this point, instead of 3 point we can consider these points and define the, by using the same formula one can find that we have the different interval. So, the x axis is 0, 1 by 3, 1 by 2 and 3 by 4 and 1. So, we have 1, 2, 3, 4 interval, therefore, we need a 4 functions. Here this 4 function to, because in the each function we need to find the, each interval we need to find the line joining of 2 points. Applying the same formula, then one can get this piecewise functions. The function is given here, the first one is goes here and down, then increasing and decreasing. So, here the data points are, so comparatively compare with this data points, here the data points are increasing and decreasing. We are taking only 3 points, but here you can see the data points are increasing, decreasing, again increasing and decreasing. Maybe if the points are more fluctuating points like this one, then you can just think that the points are look like this one. Then obviously, if anyone want to find the in between values, then one can use the classical interpolation to find the in between values. So, in this way one can find the interpolation between given set of point. This method to find the continuous function which passing through the given set of point, we can call it as the classical interpolation. Throughout this lectures, whenever we use the word classical interpolation, it means that the line joining 2 points in the given set of data points. Fine. Then what is the drawback of this classical interpolation is, so whenever, as mentioned here in the graph, whenever the data points are irregular, it is give the continuous function, the piecewise continuous function. In this interval, the function is differentiable. If we have the 4 points like this one, then you connect this point and this point and this point, the function is continuous this interval, as well as this has the smooth curve here, therefore the function one can say this is a differentiable function. But whereas in the real time data, say for the stock market data, the fluctuation is more high. Also one can take the EEG signal data, the pulse of the human bodies, one can take the curves are more highly irregular data, but you cannot find any closed interval, the curve is smooth curve. So it is a more irregular curve. So in such cases, the classical interpolation will not give the exact approximation of the in between points. So now we need a tool to interpolate such a irregular data. So we already discussed in our previous classes, fractal is a fine structure, and whenever you are taking zoom in, it will gives the fine structure as well as more irregular data. So if one can find the continuous function by meaning of any iterated function system, if the continuous function passing through the given set of data, then we can say this continuous function constructed by using the iterated function theory will give the better approximation. So here one can observe that whenever there is a decreasing and increasing, the curves are getting peak and down. So you can imagine that if the data are more irregular, the classical interpolations generate the curve like this one. Say for example, if you have the data points like here and here and here and here and here, it will give the function like this one and this one and this one and this one. So you can observe that when you are zoom in this curve, between these two interval, between these two data point, the curve is continuous. Obviously due to the smooth nature, it is the differentiable functions, whereas in the real time scenarios, there are many data, it is more fluctuating. For instance, consider the fluctuation of the stock market data and the human EEG signals, it has the more fluctuation. If anyone want to approximate this type of curve by using the classical interpolation, it will give the smooth curve, whereas if someone use the fractal interpolation curve, it will give the more irregularity rather than the classical interpolation. So in upcoming lectures, we are going to discuss systematic way to construct the fractal interpolation function in the metric space. Especially we are going to use the iterated function system to construct the fractal interpolation function as the attractor of some special type of iterated function system. So let us discuss in the upcoming classes. Thank you.